Hi, this is a video for SOEN6441, Advanced Programming Practices. This is for week 9. So this is the second lecture and the last lecture on design patterns. So for this lecture, I've chosen the adapter pattern and the strategy pattern. So I have created new examples for these two compared to what I used to have. So these examples are more related to the project, what you have to do. It's important, again, I repeat, I did say that also for the previous two examples I gave, two patterns and their examples I gave, that you understand that what I'm asking you to do in the project is not exactly what is on the example. Okay? So don't think the exercise is about doing exactly what I've shown in the example in the slides here. Might be slightly different. So let's go to, or maybe let's go to the web page and see where we are. So at this point, we're on week 9 here. So this is the lecture here. And then week 10 is going to be the presentations for build number 2. So I'm expecting you will come up with some questions in the live lecture for this week, if you have some questions. So note that there's no lecture because there's the presentations. There's no lecture on week 10. Then on week 11 and 12, we'll be talking about fault tolerance and exception handling. And then finally, we'll talk about Java generics. And then on week 13, it's going to be the presentations of build number 3. I'm going to give you build number 3 on week 11. And then that's going to be the end. And it's going to be the final exam at the end during the final exam week. One of the things is also some of you may have seen that the final exam has been scheduled for April 29th from 9 a.m. to noon, which is going to be much better for the people that are on the other side of the planet in India and Iran. So we have quite a few students that are still there. So this time is much better for you, as well as for us, that's also here. Okay, so let's go to this design pattern here. Oh, should share the entire thing. Sorry about that. Let's go here. So let's start with the adapter. 36, I believe. Okay, adapter. So the two patterns I've chosen, these are patterns that I will be asking you to implement for build number 3. Okay, so you don't have to implement them for build number 2. Important to understand. So, so you have to implement, you will have to implement the adapter pattern and the strategy pattern. The example I'm going to give here, it's actually kind of the same thing as what you'll need to do for the in your project. Though again, I repeat, there might be differences. So we just look at this example as an example. Okay, it's not about copy paste the code into your project. Pointer here. Okay, so what is the adapter pattern? Why would you want to use the adapter pattern? What kind of problem are you looking for to solve using the adapter pattern? So like any adapter that you have in the real world, like when you have your computer, most computers will use, or laptop computers will have an adapter whose goal is essentially to transform the electricity that you have on the wall the 110 volts to electricity that is usable by your laptop computer, which is likely to be much lower voltage. So then what this adapter is doing, well, it plugs in the wall, which has the electricity in the wall has a certain specification, and then it transforms the electricity into the electricity specifications for the input of your computer. Okay, so it's a functional specification adapter. It changes the specifications by which you are plugging these two ends of the adapter. Also, the shape of the plugs that you are using are different. Okay, so that's the same concept that's happening with the adapter pattern, which is of course a software adapter pattern. Okay, so what's the intent of the adapter pattern? First of all, convert the interface of a class into another interface that the client expects. So it's possible that you have your existing implementation for a certain class that provides you a service inside of your implementation. In the example, what I'm going to use is that maybe your example in your game, you are reading a file, a mat file that is on your disk. You read this file that is in a certain format, and basically your game engine is calling a certain method in this class that reads the file. Okay. This method has a certain name, it has a certain number of parameters and return type. Okay. Then what's going to happen is that now I'm going to ask you to read from another type of file. And I'm going to ask you to actually create another class that is going to read from this other file type. And then I'm going to ask you to actually implement an adapter that makes a bridge between these two classes so that you're able to use this new class as an adapter, as an adaptee actually of the class that you already have. So the intent, therefore, is to that the adapter lets classes work together that could not otherwise because of incompatible interfaces. So the assumption is that these two classes, these two file readers, they are separate classes and they use a different method name. So if you want to actually use them in the game engine without changing much of your code, and somehow you need to have some kind of adapter. That's what this adapter is doing. The assumption using the adapter pattern is that these two classes that have the same functionality, you cannot change them. Okay, so you cannot change the method name, you cannot change the types and so on. Okay. Now, let's see what is the structure of this pattern. So here you have the client. So in this case, that would be your game engine. And then the target is, in our case, that would be the file reader. So this target here is a file reader class that reads from this text file that you have on the disk. Then there's a method here that will read the file and actually create a map, and then the game engine receives the map that has been created from this text file by this class here. So that would be your file reader would be the target class, and your game engine would be the client class. Then we assume I'm going to ask you to write and to read from another type of file. Still going to be a text file, but it's going to be a different format of file. Okay. So then you're going to have to write another file reader. So I'm going to ask you to write another class that is totally unrelated to this other class here that you wrote. So I'm going to ask you to write another file reader, and then somehow make it so that the client can interchangeably use either this one or this one, even though they're not of the same type. Okay, so that's basically what I'm going to ask you to do. Okay? That's what's happening every time you want to justify the use of an adapter. is that you have two separate classes, totally unrelated, that are achieving the same goal, but they don't have the same interface, they don't have the same methods names, they're not of a related type. And then you want to use them somehow, be able to use them interchangeably to achieve the same goal, but by having different, mechanics and different method names and types. What you do is you actually design what's called an adapter. The adapter is a new class that's going to be a subclass of the type of the target class. And then what it's going to do is actually it's going to contain an object of the type adaptee inside of the adapter, so that, and then it will implement exactly the same method here as the target. So when the client is using this target class here, they're using a certain method, for example, read file, which is reading a certain file and then creating a map, which the client, your game engine, will then use. So what you're going to do is you define this class here, going to be a subclass of this, and it's going to actually override this method here. So it's going to provide another implementation for request, or the method, for example, your read file method. So that when you actually use this subtype here in this in the game engine, it's going to call this method here. What this method is going to do is going to do some processing, and it's going to use this method here, which in the adaptee file reader is reading from this other kind of file. So it's going to use this method here to read from the file to create some kind of map. In this case, in my example, it's actually yes, reading from a file, and it's creating a map, yes, but a map of a different type as what the client is actually using. Okay. So then the adapter, what it's going to do is going to read, it's going to call the method here to read from the file. It's going to create a map. Then this adapter is going to actually transform this map into the right type of map that is used by the client. Okay, so the adapter is going to enable to read from a different kind of file and then get a map and then transform it into the kind of map that the client is requesting. So essentially, that's the conditions I was just explaining. So where you use a pattern when you have a client class that invokes method defining a certain class or interface. So that's the target. And you have another class, the adaptee, that doesn't implement the same interface as the target, but still implements the same service. So in our case, we're going to have two separate classes, unrelated classes, that are going to be reading from a file, two different file types, different kinds of files. And then the other assumption is that you cannot change the existing code of either the target or the adaptee. Because if you could change the code, then you probably would design it in another way. Okay, so the assumption will be also in the assignment that you cannot change the actual code of the new either the old file reader or the new file reader. Then, if both of these things, if all of these things are true, then you need an adapter that is between the target and the adaptee. Now let's go with the example. So here I have my text file reader. Okay, so that's my target. By the way, this code is available on the web page. Okay, just by on the side of the slides. Okay, and on the web page. So the file reader is my targets here. So I have my game engine, and it's actually now using this method here of this class to read from a file, text file, and then create a map that my game engine is then using. Okay. So that's what I assume that you would have already in your implementation. Of course, here I'm not implementing all the details. Okay. The important thing is that you provide the string, which is supposedly the name of the file, and then you actually are implementing something which is reading the file and then creating the map. And then the type of map I'm creating is of the type map. Okay. And then you essentially return this map that was created as a result of reading the file and creating the map. So that's what I'm assuming you already have. Then what I want you to do is to create another, because I'm going to ask you to read from another kind of file for the game. There's different games for different games you might see online for this. There's another game that provides that has the same kind of map, but has a different format for the files that it actually uses. So I'm going to ask you to be able to read from these other files, and then design a class that actually does exactly the same thing. Okay. Here, just for the sake of the example, I'm showing that it's possible that if this file reader here, or the method that you are using, is actually achieving the same kind of purpose, which is to create a map out of reading a file. Okay. It's the same concept that it's providing, except that here it is actually going to, of course, require a different kind of processing to read from the file, because the file is a different syntax. And then it is here, this method is creating, yes, a map, but is of another class. The map class is not the same. So either there might be some little differences as to what is the map class as implemented with this, along with this, this file reader. So the example here, it's not always happening, but here the example is showing that you can be reading this, in this case, I'm assuming in the example that it's a JSON, it's a file that is in a JSON format. You read from this JSON file, and then you create a map, but a map of a different kind that compared to the original map here that you have. Okay. So that's the assumption here, that you have these two file readers. Okay. You can assume, for example, this file reader here is yours, and then here this file reader is the file reader that you found in another implementation. Okay. And that you cannot change it because it belongs to another implementation by its own. Then what you need to do, so this in terms of the adapter pattern, this here, what you already have is the target. This is what is already used by the client, which is your game engine. And this here is the adaptee. This is what some other thing that you want to use that achieves the same goal, but has a different implementation. So this is target, this is adaptee. Now you need to have this adapter. Now this adapter needs to be a subclass of the target. What is the target is text file reader. It's my class that I have here. So my adapter needs to be a subclass of text file reader. Because what I want is eventually my client should be able to use this here interchangeably with this here. So it needs to be as the same type. This needs to be somehow the same type as this here. That's why I'm going to create a subclass of this here. And then I'm going to use the adapter in the client implementation if I want to use the adaptee. So there's eventually, as we see here, there is going to be inside of this class here, an object of this kind here that I'm going to use to actually delegate the call to request here. I'm going to delegate the functionality of this to reading the file here and creating the map here. So both this adapter class, it is a subclass of my target, and it contains a data element, a member that is of the type of the adaptee. Okay, so you see here that I didn't change the adaptee nor the adapter, the target, sorry. Okay, and then of course, as you are creating this adapter, then you must pass an object of type adaptee to it as the constructor to the constructor, and which will then instantiate this member here. Then eventually, what you want to do is to have this adapter to override the method that the game engine was actually using. What is this method name? Is read file, and then returns a map and takes a string. So I'm creating a read file method inside of this here that receives a string and then returns a map. So this way, if I use the adapter in the client, then I'm going to actually, and I'm calling read file, it's going to call read file of this here. What does read file of this here do? It's actually calling the read JSON file type method of the JSON file reader. Okay, so it's calling this method here. Now this is going to read the file and then create this map of type other map. Of course, what I want is to have an object of type map, not an object of type other map. So after I read the file and then created the map that is returned by this, which is of type other map, then I should have a translator that will translate this other map into a map. Okay, here, of course, I did not implement this here, but that's the objective here. That this method here is basically translating an object of type other map into an object of type map. So this way I can actually return the translated map that was output by this into an object of type map. So this is the return of this is other map, the return of this is map. So then I actually call this read file on this object here, which is reading the file here, returning an other map here, and then I call translate to translate this other map into a map, which is then gets to the to my client, my game engine in our case. So here, this is just to demonstrate what we'll be using, what's going to happen. So, for example, let's assume here that this is your game engine. What it used to do is to create an object of this file reader here, and creating an object of type map, and then you are actually calling read file in your file reader, and then which will actually would actually be returning your map, reading the file and creating your map. So that's what you used to have. So what you want to have is then being able to use an object of type JSON file reader to actually read in a file of type in the JSON syntax and actually use it, call it in exactly the same way as you used to call your normal or old file reader. So what you want to do is say map is equal to variable name dot read file and then a string, exactly like you used to have here, so that you can use either interchangeably. Okay. So the way to do that, you essentially create a file reader adapter that you feed a JSON file reader to it, so that now the adapter is now connected to a JSON file reader, so that when you actually call read file here on your adapter, that it will eventually make the JSON file reader object to read the file, create the other the object, the map object of type other map, and then eventually translate it into a map object, which you eventually will get. Okay. So this is how the adapter is working, and that's pretty much exactly what I want you to do. Except that it's, you don't need to have, of course, here you can assume that the two map files will be of the same type. So you will not need to have this translation here in between the two. It's not necessary. Here just to show that it can actually do a translation. This is here a variation of the adapter. So this adapter here that I've shown is an adapter that works in only one way. So it allows you to have an adapter that adapts a JSON file reader and makes the client think that this is actually a text file reader. Okay? So that's a one-way adapter. The other way, you can actually design a two-way adapter, which is often called a class adapter. Essentially a variation of the adapter. What it's doing is actually achieving both of the different ways at the same time. Well, it can only be used in one way at a time, but it is designed so that it can actually instantiate it in either a forward or the reverse way. So it's a two-way adapter. So what it does is essentially that it uses an interface to actually provide either of the two ways. Okay. So the classic adapter is often called object adapter, and this one is called a class adapter. So here, both of the target class and the adaptee class will actually implement a specific, an interface. What you would need to have, you might think if you look at this here, then you need to have this adapter. So if it is to be in a one way, then the adapter needs to implement to inherit from target. So you might say, well, I'm going to make my adapter inherit both from target and the adaptee. Well, of course, in Java, you don't have multiple inheritance. You can only inherit from one class. If you would use a language that has multiple inheritance, then you could actually use, that's actually a very good example of use of multiple inheritance. But in Java, we don't have that. So essentially, we will use an interface so that we actually, this adapter actually implements, inherits from the target, and as well as implements the interface of the adaptee. Okay. So that's actually somehow doing some kind of multiple inheritance, but no, it's actually inheriting one class and then inheriting an interface that is the interface of the adaptee. So you see that here, that's another example because it didn't really work for file reading. So that's the classical or the classic peg example for the adapter. So it's either you have a round peg or a square peg. So this is an analogy to when you have woodworking. If you want to assemble two pieces of wood together, so you can create a hole in one of the pieces, and then you make this piece here of the same shape as the hole, and then you can somehow connect these two pieces together. Okay. So either your connection is going to be, in this example, either a round hole and a round peg, or a square hole and then a square peg. The example is, how do you connect a round peg inside of a square hole? The idea is that you design this adapter, which is another piece of wood that has a round receptacle as well as a square receptacle, so that you have somehow an intermediate piece of wood between the two pieces of wood you want to connect. So round peg and square peg. So here, essentially, I want to connect either a round peg into a square peg or a square peg into a round peg. So following my design here that I've explained here, so I will have my target, which is the square peg, and then I want to actually be able to connect a round peg into my square hole. So then I will have this kind here, and then this adapter here is going to be a sub class of this class here. And then I'm going to need to have an interface, which is going to be the interface of the square, the interface of the round peg. Okay. Then eventually what I'm going to end up having is I'm going to end up being able to have either a round peg or a square peg. And then I can have my peg adapter that can receive either a round peg or a square peg. And then I can either use the method, depending on which one is connected in which way. Then I can either call insert or insert into hole. So insert is my method of the square peg, and insert into hole is my method of the round peg. So this is actually how I end up having a two-way adapter. Okay. So it's essentially using exactly the same pattern as the adapter, except that it's using some kind of multiple inheritance by having my adapter being both a round peg and a square peg. And then depending on which object type I use in my constructor when I create my class adapter object, then it's going to be either a one-way, a square to round hole adapter, or a round to square hole adapter. This one you see much less often. It's not very often that you want to be able to do both directions. And that's not what I'm going to be asking you to do in the project. Okay. So let's go to the next one, which is the strategy. Strategy is 83. So here, what we want to achieve eventually in our game, our Warzone game, so we have players. At this point, the players are all the same kind of players. And then you may safely assume that they are actually human players, because human will enter commands, or if you have implemented a GUI, then the players are all relying on the user interaction to actually create the commands. Okay. So eventually, what we want to achieve is to have automatic players, essentially computer players, that will make their own decisions. Eventually, I'm also going to ask you to have as well a human player that is implemented in exactly the same way as the computer players, except that it's going to rely on user interaction to make decisions. So how do we implement that? There's a lot of different ways. You can use a bunch of if statements to branch on different behavior, depending on what kind of player that is. But that's very unhandy, especially if you want to add more computer behavior later on. Strategy pattern exists to actually enable you, and also it would be not so handy if you want to dynamically change the behavior at a runtime. So essentially, the strategy pattern exists to provide possibility for an object to change its behavior depending on what strategy it has adopted. And you can actually change the strategy dynamically at runtime. So the strategy is not set up as you create the object only. It can actually be changed at runtime. So that, for example, you could have a player, imagine a Warzone game, and you have a player which is a pacific player, never attacks. But then if you attack this player, then it becomes aggressive. Okay? So you need to have a way to actually be able to switch the behavior of the player dynamically at runtime. So that's also some of what a strategy pattern provides, to be able to change dynamically at runtime the behavior of an object. So what's the motivation? Sometimes we may want to change the behavior of an object depending on some condition that are only to be determined at runtime. Okay, so if you are to create an object and its behavior, yes, can be different, but will not be able to change at runtime, and possibly you don't need the strategy pattern. Or what we want also, what the strategy pattern is good at, is to be able to later on add more different behavior later on in the existence of the project. So in our case, we're going to be able to add possibly later on many other kinds of player behavior without actually changing the code of the previous that was there previously. We'll just have to add a new class that provides its new behavior, and the existing code will not need to change. Okay, that's one of the great advantages of the strategy pattern. What's the intent of this pattern? Define a group of algorithms that applies to a family of classes. So in our case, it's not a family, it's just a player. You could imagine that you could have inheritance relationships between different kinds of players. Then you could actually define the behavior across different kinds of players. Okay. In our case, there's going to be only one kind of player. And then depending on what strategy it has adopted, then it will eventually change behavior. Okay. Very important when you do the implementation of your different kinds of players. If you think I'm going to define subclasses of players, let's say I'm going to say neutral player, defensive player, aggressive player. If you start thinking I'm going to have a subclass of player for each of these, straight away you're wrong. Okay? You should not add more classes of players to implement the strategy. Second, you want to encapsulate each algorithm separately. So you want to separate each of the varying behavior so that they don't interfere in the code with one another. Okay, so that you can later on add new varying behavior without having to change the code of the behavior that you already have. And then make the algorithms interchangeable within that family so that you can have player objects, and then you could actually interchange these behaviors across the different kinds of players that you may have. In our case, there's going to be only one kind of player, but it's going to have the possibility of having different behavior using strategy. Then what's the consequence of this? Strategy pattern lets the specific algorithm implemented by a method vary without affecting the clients that use it. So here's the structure of the strategy pattern. So first of all, here's the strategy class. The strategy class can be either an interface or it can be an abstract class. In my specific example, I've used an abstract class. Why? Because I wanted to have the possibility of my strategy to actually have data members. Okay. As we will see, there's going to be some methods here that are going to implement some behavior that the context, or in our case, the context is going to be the player. So the player is going to use these methods here. So, and then in our case, these methods are going to be implementing some decision making as to what kind of orders the players are making. So then when you want to decide, for example, where do you attack from and where do you attack to, let's say you do an advance order, you have to decide from where you actually want to move your armies to where to other country or territory you want to move. So in order to make this decision, you need to be aware of the map. So basically the strategy class is going to contain a data member map so that these methods here can actually have access to the map in order to make a decision as to, for example, if it's a deploy order, where does it deploy, an advance order, where is it advanced from and where does it advance to? You need to know the map in order to make this decision. So it's going to be a strategy class, and then eventually there's going to be a neutral player, there's going to be a random player, and then there's going to be a defensive player. Okay. So neutral player is going to do nothing. The random player is going to make random decisions as to what it will do, and then the defensive player is only going to be able to deploy armies on his existing territories. These are all going to be each implemented. There's going to be one class for random, one class for neutral, and one class for defensive player. They are each going to be a subclass of strategy. Then here, context is going to be our player class. Then the player is going to adopt somehow the strategy, either neutral or random or defensive. And then when you're going to ask the player to issue an order, then it's going to decide, depending on what kind of strategy it has adopted, then it's going to essentially call these methods here to decide what kind of order it wants to issue, depending on if it's random or if it's defensive or if it's um, depending on what kind of player it is. Okay, so we're going to make different decisions depending on what kind of strategy it is actually implementing. So in fact, the player contains an object of type strategy. And then when you call this method here, which in our case is going to be the issue order method, when you call issue order on the player, then the issue order method is going to call the methods of the strategy that it actually has adopted. You see this method here, which in our case is going to be the issue order, is going to somehow delegate the behavior. It's going to delegate its own behavior, or use to, in order to define its behavior, it's going to use the behavior that is defined inside of the strategy that it has adopted. So the context is the class that we want to have the behavior vary depending on what kind of strategy it actually is using. So in our case, it's going to be the player. So the player is going to contain an object of type strategy, which is this one here. And then it will provide also, the player will need to have a set strategy method that allows you to actually either set the initial strategy or change the strategy if something happens to this player and then wants to switch between strategies, as I said earlier. And the strategy is a superclass of all strategies or an interface. And then the concrete strategies are all the different kinds of behaviors that you want to implement. And then for each different kinds of behaviors you implement, if you have a player to adopt this different behavior, then the player is going to start behaving in a different way. So here is our player class. So this is here the context of the strategy class. Okay? So this is the class that you already have. This is the class that you want to somehow have a varying behavior. Okay? How do you somehow inject this varying behavior? By having the player contain an object of the strategy class. In our case, in the example, it's called player strategy. So player strategy is this here. Then you implement a set strategy in your player that actually receives an object of type player strategy, which is basically one of the subkinds of the player strategy. So if you want to change to neutral, then you create a new neutral strategy and you set strategy, new neutral strategy, as we will see later. Then here, it's your good old issue order function that we have already on the player. So when the game engine wants the player to create an order, they just basically simply call issue order on the player. Then the player is making decision as to what kind of order to create, and then what is the specification for this particular kind of order. So there's, depending on what order you are, the player will decide to issue, then there's going to be some decisions to be made, what's going to be the target of this order. And these decisions are actually going to be implemented in the concrete strategy. So you see here, when I'm calling issue order, it's actually calling create order of the strategy object that is inside of the player. So that if I change the strategy, then it will call a different method in a different class. So it calls create order, this returns an order, And then this order is put in the list of orders as we saw earlier on. Now here's my strategy class. It's actually called player strategy. It's an abstract class. So this here needs to be either an interface or an abstract class. Here I made it an abstract class because I wanted to be able to have data members inside of my superclass here. As I explained earlier, if you want to make decisions as to what's going to be the targets of your orders, then you need to know what is the list of, essentially what is the map, and then what are the players that you could potentially target. Yes. So, and then you need to have a constructor that will actually receives these. So the game engine is essentially going to give references to this player strategy object so that it has a reference to the map that enables it to make decisions according to the state of the map. Then here, this is the list of abstract methods that must be implemented by every of the subclasses of order. So create order is the method that the strategy is going to use to determine what kind of order it's going to create. Then depending on what kind, then it's going to have to make decisions, for example, as to what is the country that you may want to attack? What is the country that you may want to attack from? What's the country you may want to move from, or what's the country that you may want to defend? So depending on what is your strategy, for example, if you're a defensive player, then either, for example, you might want to add more armies to your countries that have less number of armies. Depending on your strategy, you, for example, to defend would be identified as different kind of territory. If you're very aggressive, you may want to add always more armies on your biggest country, on your country that contains more armies, which is a different strategy. So depending on what kind of strategy we're talking about, for example, to defend would identify a different country in your own countries on which you want to add more armies. That's the idea here. Depending on what kind of player you want to implement behavior for, then you would implement different code here inside of each of these, which is what I'm providing here. Well, first of all, the most simple, the neutral player. The neutral player, the concept of the neutral player is this player does nothing. Okay? It just sits there. Maybe it has a country, but when its turn comes, it basically does nothing, never issues any order, it does nothing. So essentially what, when you call issue order, when the game engine calls issue order on this player, this eventually calls create order of its strategy. If its strategy is the neutral player strategy, then create order actually returns null. It never creates any order. Now, because it never creates any order, it does not need to know. It's irrelevant for this player. Where do I want to attack, to defend, and so on? I don't target anything. I'm just doing nothing. So I don't need to know any of these. So this basically just all return null. Okay. So that's a very simple one. Now, what if I want to create a defensive player strategy? So this one will want to protect its own countries, okay? And it's not going to want to attack. Okay. So here, the main thing here is to defend. So what is a to defend? To defend, here, I wrote here, a defensive player decides to defend its country with the most armies. So it wants to put more and more armies into its country that has the most armies in, as to have a better success in at least surviving an attack that comes from another army, another territory. So it wants to survive in one country that has the most armies. That's the strategy. So it will, when it tries to define what country to defend, here it actually finds what is the territory that it controls that has the most army, and that's the one it will try to defend. To attack, well, the defensive player does not attack. So if it ever is trying to determine where it will attack, it will basically say, I don't want to attack anywhere. So you return null. To attack from, again, I don't attack, so return null. Where do I move from? I don't move. I just stay where I am, and I put more and more armies in my territory that has the most armies. So to move from, irrelevant. So create order, what is it that this player does? It actually can only deploy. And then where does it deploy? It deploys in the country identified by the execution of to defend, which is the territory that they control that has the most armies. And then how many armies? A random number between 0 and 20. So here you understand here that this is very simplistic to what compared to what you have. Okay, it's just a very simple example. So you see here that these two are very different. This one does nothing, and this one is basically can only do deploy, and it will deploy only in its country that has the most armies. Now here's another one that I wrote, which is called a random player strategy. Now this one, its name says it all, it's basically going to use random numbers to make every decision. So my create order method here makes it so that it's going to either want to deploy or advance. So it's going to deploy on the territory that is returned by my function to defend. So of course, on my function to defend, what it does is that it determines a random country that is owned by me. Okay. And then I'm going to deploy from 0 to 20 armies on one of my countries. That's basically what it says. And then advance, so it may choose to advance, but then it's going to advance from any of their territories to any territory that is on the map. Okay. Here, this particular implementation does not implement adjacency. Okay. So you can essentially advance from any territory to any other territory. So it's going to advance what is going to be the territory that it's going to move from. It's going to move from a, again, random territory of my own. And then it's going to attack, it's going to attack to any territory on the map. Okay. So you see then that these here I would have, and I can actually change this the strategy of the player by essentially call the set strategy on the player. So at one point the player can be neutral. Then if I call set strategy with a new random strategy, then suddenly the same player becomes a random player. Okay. And I did not change, there's absolutely no code inside of my player class that has an if statement that actually is switching depending on what is the type of the player. Okay. So it makes your player class much more simple. And it also makes it so if you want to add new behavior, you don't have to change anything in the player class. You just need to add one more concrete strategy, and then suddenly the player can adopt this new behavior. That's what the two great advantages of the strategy pattern. You dynamically can change the behavior of an object at runtime, and you can later on add some new behavior without changing the code of this object, of this class. Then eventually, as we will see here, random, and then here is my game engine class. So here my game engine, of course, has a map and then a list of players. And here I'm creating the players. And then I'm actually telling these players to adopt the defensive strategy, the random strategy, and the neutral strategy. Then I have this loop here that is asking the players to issue an order. So you see that I'm calling issue order on the player, asking the player to issue an order. Then what it's going to do is to call create order of the strategy that is within the player. So if I'm calling issue order, sorry, let's say for player one is a defensive player. So I'm calling issue order of the player one. So it's going to eventually call the create order inside of the defensive player implementation, which is then going to call this method here, create order. And then it's going to essentially want to create only deploy orders, which are going to use these methods, this method here, to define what's going to be the target of the deploy order. And then if I'm using the random player, then it's going to call again issue order. The game engine is going to call issue order of the player, which is then going to create order of the strategy that is within the player, which is in this case the random strategy. Then it's going to branch to the create order of this class, which is then going to run the code that implements the random strategy. Okay. Eventually, I could, it's not what my driver does here, but I could actually, as this loop is going on, I could actually change the strategy by calling set strategy on any of the player. And then suddenly the players would start changing behavior dynamically as the game goes. Okay. So that's what one of the things I'm gonna ask you to do in build number 3. So please don't think that I'm asking you to do this for the build number two, which is due next week. So that's about it for this lecture. Thank you. Bye-bye.